All right, so hello everyone. So for this week, we're going to be starting chapter 5, and this is going to be introducing a really important concept in chemistry. This is the concept of the mole. And this is going to piggyback off a lot of the math and chemistry that we learned about last chapter. We're going to have to pay attention to sig figs and all that good stuff. All right, so let's get started. Again, first thing we're going to do is just introduce this concept of a mole. In chemistry, we're obviously talking about atoms, and we're trying to quantify the number of atoms that we have a lot of the time. The problem is that atoms are really freaking small. So if I have, for example, just like my water bottle here, if I wanted to quantify the number of atoms in there, I could do it, but I would have some huge number, like, just a ballpark, it's something like 1 times 10 to the 25th or something like that atoms is around what would be in here. That's obviously a really large number, right? 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 25, right? That's that number that I'm representing there. That's obviously a humongous number. Right? So it's not really convenient to talk about number of atoms in terms of just the actual count of atoms. Instead, chemists use a different measurement, which is called a mole. Okay, mole spelled just like the animal, but then we abbreviate it M-O-L-E, kind of like how we have grams and we abbreviate it with G. Okay, so what is a mole? Well, just like if I said that I had a dozen eggs or a dozen cookies, or even like a weirder context, like I have a dozen friends, you would know that that meant 12 of whatever it was I was talking about, 12 eggs, 12 cookies, 12 friends, because that's what a dozen means, right? So a mole is exactly analogous to this, except for a mole is equal to 6.022 times 10 to the 23rd. And actually it's 6.0221 times 10 to the 23rd is the number that's given on our constants page. But if I said that I have a mole of eggs, that would mean that I had 6.0221 times 10 to the 23rd eggs. That's a huge amount, right? But that's just what it means to be a mole. Again, analogous to a dozen. It's just that amount of whatever it is we're talking about. And of course, we usually use it in the context of a mole of carbon atoms, for example, or a mole of CO2 molecules or something like that. If I had a mole of carbon atoms, that would mean that I had 6.0221 times 10 to the 23rd carbon atoms. Okay. And again, we can find it on our constants page. It's actually over in this chunk here. If we zoom on in, this is 1 mole is equal to 6.0221 times 10 to the 23rd molecules, or whatever it is you're talking about, whether you're talking about molecules, atoms, or eggs. I mean, it probably wouldn't be able to find a mole of eggs if you tried. That's just a huge amount. But nonetheless, it could be whatever it is that we're talking about, right? So this is what we're going to be using. We're going to get in the habit of using all of these digits, everything that's given to us on our constants page or our periodic table. We always use all the digits. Don't get lazy and randomly round. Could give you a different answer and it'll be marked wrong. Okay, so just get in the habit of using all those 5 digits that's given there. But that's what a mole is. And so just like we sort of were taking these information from this constants page and using it to create these conversion factors, we're going to do the same thing with this, this idea of this mole. The 6.0221 times 10 to the 23rd, that's what's called Avogadro's number. Avogadro was a dude. He's the one that came up with the whole concept in the first place. But yeah, so we have 1 mole equals 6.0221 times 10 to the 23rd, whatever it is, let's say atoms or molecules or whatever, and we're going to create a conversion factor much like we did before. So we can either write it like this, or remember, we can also flip them upside down. Say atoms, because that's what we're going to be talking about at first. So let's just, but yeah, so this is kind of how we're going to be able to use this in our math now, is to convert as a conversion factor. Okay, so this will help us go from number of moles to number of actual atoms, or from number of atoms to number of moles. And again, atoms is what we're going to be talking about at first. So that's what I kind of want to emphasize here. Okay, so for example, calcium is the most abundant metal in the human body. A typical human body has about 30 moles of calcium. Determine the number of calcium atoms in 30.00 moles of calcium. And again, notice that we're going to have to pay attention to sig figs. I'm given 1, 2, 3, 4 sig figs in my 30 moles, so my answer should have 4 as well. And how am I going to set this up? Well, I'm going to start out with the quantity given, which is the 30.00 moles of calcium. And then I'm going to use that Avogadro's number, that conversion factor, right? So remember, I looked on my constants page. I found this right here. That told me 1 mole was equal to that many molecules, or in this case, atoms. And then I turned it into a conversion factor, one of the two directions, right? So I'm either going to use 1 mole is equal to 6.0221 times 10 to the 23rd atoms. So 1 mole of calcium is equal to 6.0221 times 10 to the 23rd atoms of calcium, or 6.0221 times 10 to the 23rd atoms of calcium is equal to 1 mole of calcium. Those are the same thing, right? So which one am I going to use in my math above? Remember, I want to always pay attention to units, and I want my units to cancel out so that I'm left with what the quantity that I want, which is in this case atoms. So I'm going to use this form over here. I'm going to say 1 mole of calcium is equal to 6.0221 times 10 to the 23rd atoms of calcium. Okay, and then I'm just going to punch this into my calculator. What I get on the other side is 1.80663 times 10 to the 20, whoops, it's not a 20, times 10 to the 25th. And remember, we're going to do this in the same kind of 3 parts that we did first. So the first step, punch it into your calculator. What do you get? That'd be this answer here. Then I'm going to go back and I'm going to cancel out my units, and what I'm left with in this case is atoms. That's good. That's what I want. And then the last step is going to be sig figs. I have 4 sig figs in this number here. I have 5 in Avogadro's number, so I'm going to round to 4 sig figs over here. So my final answer that I would give would be 1.807 times 10 to the 25th atoms. This would be my final answer here, rounded to the correct number of sig figs. Okay, so that's A. B, I'm going the other direction. It wants me to go from the number of calcium atoms, in this case 1.00 times 10 to the 20th, and figure out how many moles of calcium are in that sample. So again, I'm going to start with my given quantity of 1.00 times 10 to the 20th atoms. And then I'm going to use this conversion factor that I'm going to grab it from my constants page here. But this time I'm going to flip it compared to what I used before, right? Because now I want atoms to be on the bottom. So 6.0221 times 10 to the 23rd atoms over 1 mole. So I punch that into my calculator. 0.1661. Then I'm going to go back and do my units. Atoms cancel with atoms, and I'm left with moles. And now I'm going to worry about my sig figs. I have 3 sig figs in my initial answer, so I should have 3 in my final answer. So 0.000166 moles of calcium is equivalent to 1 times 10 to the 20th atoms. Okay, so again, similar to what we saw before, it's all about using this, in this case, this one particular line from our constants page, turning it into a conversion factor and using that to either convert from moles, using that to convert either from moles to molecules or atoms, or from atoms or molecules to moles, right? Can go either way, depending on which way I flip that conversion factor. The whole atoms or molecules thing, remember, if you just have calcium all by itself, that would be a calcium atom. But if you had something like calcium oxide, you would call that a molecule. Okay, anything more than one atom combined. Okay. Even easier than, so first of all, if we had a machine that could actually count atoms within the chemistry lab, we wouldn't bother using our balances at all, right? We wouldn't talk about quantities in grams if we had an ability to actually count atoms, but we don't. And so the closest thing that we can do to counting atoms is to measuring mass, and then convert that to number of atoms using that information, right? So if I took a sample of calcium and I massed it out to 10 grams, we would be able to convert that 10 grams into number of calcium atoms, okay, or moles of calcium. So let's see how to do that. That's going to be using what's called the molar mass of a substance, okay? Again, we're going to start by just talking about atoms. We'll move on to compounds later. But yeah, I mean, actually, even easier than this, let's just say, so this is information that we get from the periodic table. If we zoom into carbon here, we talked about how this number right here represented its average atomic mass, okay? It actually also has another meaning, which is the molar mass. What does that mean? Well, it turns out that 12.0107 grams of carbon is the same thing as 1 mole of carbon. All right, so those numbers on that periodic table, it represents the average atomic mass. We talked about what that is. We're now learning that they also equate to the molar mass of an element. And we can use that information in one of these kind of stacked conversion factors. So written like this, or we could flip it around. 1 mole of carbon is 12.0107 grams of carbon. These are the molar masses of this particular element, and we would use it like this in this little fraction form if we wanted to convert from grams to moles or moles to grams. Okay, so we could always pull that information directly from the periodic table and then make one of those conversion factors. Okay, so let's just do some examples here. Example 1, we're going to cut, if I have 25.00 grams of carbon, how many moles is that, right? So 25.00 grams of carbon to moles. I'm going to start with the quantity that's given. That's the 25.00 grams. Now I'm going to use that molar mass, right? And in this case, I want to go from grams to moles. So I'm going to want to make sure grams cancel out. So I'm going to use this version right here. All right, and again, get in the habit, because this is going to be really important for getting these answers correct. You need to be pulling all digits from the periodic table. Don't go start arbitrarily rounding this to 12 or something like that. You're going to pull 12.0107. Every single time, get in the habit of using all the digits that are given. All right. So I'm just going to punch this into my calculator, right? We're going to do these calculations as always in like 3 steps. First is just punch it into the calculator. So this would be 2.08147 is what my calculator spits out. Then I'm going to go back and do my units. Grams cancel, and I'm left with moles. Good, that's what I want. And then lastly is worrying about sig figs. So 25.00 has 4 sig figs. And so my final answer should have 4 sig figs. My mass has 6. If you're pulling all your digits from your periodic table, you're not going to be limited by the information on the periodic table. That's the whole reason why we pull all those digits, is so that we don't fall into a situation where that's what's limiting us. So final answer here would be 2.081 moles. That's how many moles are in 25.00 grams of carbon. So notice that I just grabbed that information. This conversion factor here, I pulled right from the periodic table. What about the number of moles in 10.50 grams of helium? So I'm going to start with my 10.50 grams of helium. That's what I'm trying to get to, and I'm trying to go to moles. So again, start with the 10.50 grams. Now, how am I going to convert from grams to moles? I'm going to use the molar mass on the periodic table. So let's get rid of this one. We got to find helium. All right, that would be this guy right here. So I'm going to pull this number here, this 4.003. And this is telling me that 1 mole of helium is 4.003 grams of helium, or I can flip it the other way. 4.003 grams is 1 mole. All right. And looking at my problem, I have grams on the top. That's my starting quantity. So I'm going to want to make sure to use this version over here so that grams cancel. So times 4.003 grams is equal to 1 mole. Again, step 1, just punch it into your calculator, see what comes out the other side. I get 2.6236233032. I'm going to go through and look at units. Grams cancel, and I'm left with moles. Good, that's what I want. And then lastly, to look at sig figs, I have 4 sig figs in this number. So I should have 4 in my answer. Actually, I have 4 in my mass too. So that means I should have 4 in my answer, which means that I have 2.623 moles as my final answer. Okay. We could do the same thing with sodium. I'm going to do this one fairly quick. It's 15.75 grams of sodium. I want to go to moles. So again, I'm going to start with my initial quantity. It's a good idea to pause and try to do this one on your own, and then see if you can't, you didn't get the same answer as me. Okay. So now I'm going to go get the molar mass of sodium. That's this one over here. It's a long one. Oh, I need to. Oops. 9897. Punch that into my calculator. Grams cancel, and I'm left with moles. And then I need to make sure to have 4 sig figs. So 1, 2, 3, 4, 0.6851 moles. Okay, and again, got to make sure that we have the correct number of sig figs and the correct units in our answer. All right, so this little diagram here is kind of telling you how to go from one quantity to another. So for example, if I wanted to go from grams to moles, I would divide by the molar mass. If If I wanted to go from moles to grams, I would multiply by the molar mass, right? So that's just talking about which way do you flip that conversion factor. Likewise, if I wanted to go from moles to number of atoms, I would divide by Avogadro's number. And if I wanted to go the other way, I would multiply by Avogadro's number. Notice this also means that we can go from, say, grams to atoms by first converting to moles and then multiplying by Avogadro's number to get to number of atoms, right? So we can go from grams to number of atoms by jumping through moles first. Okay, so we're going to do that real quick now. Go two different directions here. First is going from 0.515 grams of carbon all the way to atoms. Okay, so how am I going to do that? The first thing I'm going to do, well, I'm going to start with my 0.515 grams. I'm going to look on the periodic table for carbon. That's that 12.0107. And I'm going to make sure to have it such that grams are on the bottom. So 12.0107 grams is 1 mole. So if I stopped here and just punched it into my calculator, my final answer would be in units of moles. But if I want to go all the way to atoms, then what I'm going to do is use Avogadro's number with moles on the bottom and 6.0221 times 10 to the 23rd atoms on top. Now I'm going to punch this into my calculator. I get 2.58218 times 10 to the 22nd. Go through, use a different color actually. Grams will cancel. Now moles will cancel, and I'm left with atoms. And then the last step, finding the correct number of sig figs. I have 3, right? I don't count that leading 0. So I have 3 in my initial measurement. I have more in each of these subsequent numbers, more in the molar mass and more in the Avogadro's number. So that means my final answer will be 2.58 times 10 to the 22nd atoms. Okay, and what you want to try to do is get in the habit of doing this calculation in your calculator all in one shot. So do 0.15 or 0.515 divided by 12.0107 times 6.0221 times 10 to the 23rd, all in one. Breaking it into individual steps, A, takes longer. You got a limited amount of time on the exams, no point in doing it in a way that takes longer. And B, it makes it really easy to make either a rounding error or to just miscopy a number, right? So rather than doing these calculations in multiple steps, start getting in the habit, start learning how to put them into your calculator all in one shot. Okay. And now I'm going to go the other direction. So now I'm going to go from 6.89 times 10 to the 18 He atoms to grams. Oops, it's G. So I'm going to use the same conversion factors, but I'm going to use them in the opposite way. So I'm going to start out with my 6.89 times 10 to the 18 atoms. What's going to be my next step? If I want to get to grams, and I'm starting in atoms, I first have to convert to moles. So I'm going to use the inverse of the Avogadro's number conversion factor with atoms on the bottom and moles on the top. And then I'm going to use the molar mass of helium in order to get there. So we did this before. We looked at the periodic table, and the molar mass for helium is 4.003 grams per mole. So 4.003 grams per mole. And notice I knew which direction to put my conversion factor because, just as always, I want to make sure that those units cancel out. So I punch this into my calculator, 0.1234 0.4579. Go through. Atoms cancel with atoms, moles cancel with moles, and I'm left with grams, which is what I wanted. And now I just need to make sure to report my answer to 3 sig figs. Remember, all these leading zeros don't count. So I'm going to round it to that position there. So 0.1, 2, 3, 4, 4, 5, 8 grams. Okay, and as long as you're using all the digits from the periodic table, as well as all the digits from Avogadro's number, you should be able to get at the exact same answer that I've gotten at here, right? There's no rounding that you're going to do with either the molar masses or Avogadro's number. You're going to do it all in one shot on your calculator. You're not going to stop and record intermediate points there, because that's another source of error. So make sure that you know how to do this. And this is actually a really good one to do in your calculator to make sure you know how to do it. Okay, one of the things that people, if you got a really big number, like, what would it be? Something like times 10 to the 31, it's because you didn't do this step correctly, right? You want to make sure that you're dividing by this whole thing, that whole 6.022 times 10 to the 23rd, which means that you need to put it in parentheses in your calculator. Okay, so this part B is a really great one to make sure that you understand how to put these all in one line on your calculator.